5, that is advanced SQL. We have discussed or we have finished with the basic of the SQL. Now the next topic is the advanced SQL. So shall we begin? Alright, so wait for other for 5 minutes more, right? Okay. Shall we start? Okay. So chapter number 5 is the advanced SQL. That is a more advanced part of the SQL or SQL as compared to the last one, that is the basic of the SQL. In chapter number 3 and 4, we provided the detailed coverage of the basic section of SQL. In this chapter, we cover some of the more advanced features of the SQL. We address the issue of how to access the SQL from a general purpose programming language, which is very important for building applications that use a database to store and retrieve the data. That means how to store, how to retrieve the data. And we describe how the procedural code can be executed within a database, either by extending the SQL language to support procedural actions or by allowing the functions defined in the procedural language to be executed within a database. Automatically it is used with the procedural language to be executed within a database. And we describe the triggers also. That is also one of the main part in the database. That is a part of the advanced SQL to define or to specify the actions. What are the various actions that is performed when a data or the tuple in a specified relation. So we discussed the recursive queries, advanced aggregation features supported by the SQL, and finally we described the online analytical processing, that is OLAP, which support interactive analysis of the very large data sets. OLAP. Yes, OLAP is basically an online analytic processing that is done using the SQL. Now next is accessing the SQL from programming language. So Excel also provides a powerful declarative query language, and when we write the queries in the SQL, that is usually much more easier than coding the same queries in a general purpose programming language. However, whenever we are using the database programmer, that must have access to a general purpose programming language for at least two reasons. Not all the queries can be expressed in the SQL, since SQL does not provide the full expressive power of a general purpose language. That is, there exist queries that can be expressed in a language such as the C, Java, COBOL that cannot be expressed in SQL. And to write such queries, we can embed the SQL within a more programming language. That means we are using the programming, we are using the SQL. The next is non-declarative actions such as printing a report, interacting with the user, sending the result of a query to a graphical user. That cannot be done from within the SQL. And applications usually have several components, and querying updating data is only one component, and other components are written in a general purpose programming languages. And whenever we are using the integrated application, there must be a means to combine the SQL with a general purpose programming language. And there are two approaches to access SQL from a general purpose programming languages. One is a dynamic SQL, one is a embedded SQL. So there's a general purpose programming or program can connect to and communicate with a database server using a collection of the functions or the methods. That is for the procedure programming, that is for the object-oriented programming. So general purpose program can connect to and communicate with the database server using a collection of the functions, that is either using the procedure language, either using the methods. Then dynamic SQL also allows a program to construct a SQL query as a character string at runtime and also submit the query, then retrieve the result into program variable. So it is used as a tuple at a time. And the dynamic SQL also provides components also used to construct and submit the queries at the runtime also. In this chapter, we look at to access SQL from a general purpose programming language. One is a dynamic, one is embedded. When we say about the dynamic, that means that is not constant, that is not static, but this is a dynamic SQL component of the SQL that allows the programs to construct and submit the SQL queries at the runtime. And in this chapter, we're looking for the two concepts. One is the Jdbc, that is an application program interface for the Java language. Other is ODBC. So one is a Java database connectivity, one is an open database connectivity that originally developed for the C language and subsequently extended to other languages such as the C++, C#, and the Visual Basic. And when we say about the embedded SQL, like the embedded SQL also provides a means by which the programmers or the program can interact with the database server. However, under embedded SQL, the SQL statement can be or identified at the compile time using a preprocessor. And the preprocessor submits the SQL statement to the database system for the precompilation and the optimization. Then it replaces the SQL statement in the application program with the appropriate code and the function, whatever the appropriate code, whatever the function that invokes the programming language compiler. So a major challenge that is used in mixing the SQL with the general purpose language is a mismatch in the ways these language manipulates the data. So how they are manipulating the language, how they are making the SQL. And the primary type of data is a relation. And the SQL statement also operates on the relation and returns a relation as a result. And programming language normally operates on a variable at a time, and these variables correspond to the values of the attributes in a tuple. Whatever attribute, whatever the data that is available in the attribute in a tuple is a relation. Therefore, integrating these two languages in a single application that also requires what types of data is required, what type of mechanism that is required to return the query. So first part is a Jdbc, that is a Java database connectivity. So this standard defines an application program interface, that is API, that Java programs can use to connect to the database servers. How the Java programs are using or can connect to the database servers, and the Jdbc was originally used, or it was originally an abbreviation of the Java database connectivity, but the full form is no longer used. We are only using the Jdbc. This is the program that shows public static void Jdbc example, string user ID, string password. Now we are using the try and the try and the cache block to try class for name oracle.jdbc.driver.oracle driver, then connection con equals to driver manager dot get connection. Jdbc oracle thin at the rate db or database.yale.edu 1521 unfdb, the user ID and the password, that is a PASSWT. The statement stmt equals to con.create statement. Then try, what is the try block? That is a stmt execute update insert into instructor values. So we are inserting into the instructor, then their values 77987 Kim Physics 98,000. Then cache SQL exception SQLE, then system.out.println could not insert the tuple, then SQLE. Then result set rset equals to stmt dot execute query, select department name, average salary. So we are selecting the department name and the average of the salary from the instructor, that is grouped by the department name. While rset.next, then system.out.println rset.getString department name, then rset.getFloat. So these are the various try and the cache blocks that use with the class.forename, connection con, driver manager, oracle thin, system stmt, create statement, execute update, insert into the instructor values. Everything is that is available within the update, within the cache statement, within the SQL expression. The next is stmt.close con.close. After this, there is a cache block, exception SQL, system.out.println, exception SQL. That is an abbreviation for the Java database connectivity, but the full form is no longer used. Now this is an example that shows how to use a Java or Jdbc interface. It also illustrates how the connections are opened and how the statements are executed and results are processed, how the connections are closed, how we are using the java.sql.strict, which contains the interface definitions for the functionality provided by the Jdbc. Now the first step is connecting to the database. So first step in accessing a database from a Java program is to open a connection to the database. This step is required to select which database to use, for example, an instance of the Oracle running on your machine or the PostgreSQL database running on another machine, and only after opening a connection that can help a Java program execute the SQL statements. So a connection is opened using the getConnection method of the driver manager class within SQL or java.sql, and this method takes three parameters. First parameter uses a getConnection call, that is a string that specifies a URL or the machine name where the server runs, that is possibly used with the other information also, such as the protocol that is to be used to communicate with the database. In our example, Jdbc Oracle, then we will shortly use to see why this is required. So in this example, 2000, that specify the database on the server to be used. And note that Jdbc specify only that the API, that is not the communication protocol. And Jdbc driver may support the multiple protocol, and we must specify one supported by both the database and the driver. This protocol details are vendor specific. Then the second parameter to get connection is a database user identifier, which is also a string. Then third parameter is a password, that is also a string. So one is first one is also string, that is a URL. Second is also database user identifier, also string. The next is a password, that is also a string, but we are using the security risk if an unauthorized person access your Java code. And each database product that supports Jdbc, that is all major database vendors too, provides a Jdbc driver that must be dynamically loaded in order to access the database from the Java. And in fact, loading the driver must be done first before connecting to the database. And this is done by invoking class.forName with one argument specifying a concrete class implementing the java.sql.driver interface in the first line of the program. And this interface provides for the translation of the product dependent or independent Jdbc calls to the product specific calls needed by the specific database management system that is being used. And whatever the driver that is available in a jar file at vendor websites and could be used with the class path so that the Java compiler can access it. And the actual protocol used to exchange information with the database depends on the driver that is being used and not defined by the Jdbc standard. Now these are the driver that also supports more than one protocol, and there is the subtle protocol that must be chosen what protocol the database are using to support. For example, in our example, when opening a connection with a database, the string Jdbc Oracle thin specifies a particular protocol that is supported by the Oracle. This Jdbc class path that is available with the Oracle driver, oracle.driver.oracle driver that also provides a translation of the product independent Jdbc calls into the product specific usage by the specific DVMS that is being used. Now, one more thing that is important, that there are multiple versions of the get connection method will be used that is differ in the parameter that they accept, and we present the most commonly used version over here.